Okay, now let's continue with equations and graph sketching. So for graph for exponential functions, say for example we are given y equals to a to the power x, where a must be greater than 1, then the graph will be something like this. Okay, passes through 1 but moving upwards to the right. And when y is equals to a to the power x, where a is between 0 and 1, so the graph will move to the left, upwards to the left. Okay. Now some of the properties of exponential graph: fx equals to a to the power x. The domain of exponential functions are all real numbers. Okay. The range consists of positive numbers. So remember, domain refers to the x values and range refers to the y values. And the y-intercept for exponential graph is usually 0, 1. And there is no intercept on the x-axis. When a is greater than 1, the graph is increasing from left to right, as I mentioned earlier. When a is between 0 and 1, the graph is decreasing from left to right. Okay? Now let's look at example 3. If we are asked to sketch the graph y equals to 2 to the power x, let's take some points here. When x equals to negative 2, substitute into this equation, we will get 1 over 4. For x equals to negative 1, substitute into this equation, we have 2 to the power negative 1, which is equals to half. When x equals to 0, y will be 1. When x1, y2, x2, y4, and x equals to 3, y equals to 8. Then we plot all these points on the graph. Okay, so plot all these points and then join all these points. So when we join, we will get the shape of this curve as shown in the red color. Okay. Example 4, we are asked to sketch the graph y equals to 1 over 2 to the power x. So in this case, the value of a is between 0 and 1. So let's plot some points here. If we substitute x with negative 3, the answer will be 8. When we substitute with negative 2 here, so 1 over 2 to the power negative 2 will give us 4, and so on. Okay, so let's plot all these points. So x equals to negative 3, we have y equals to 8 here. And when x equals to negative 2, we have y equals to 4. X equals to negative 1, we have y equals to 2, and so on. Right? So when we join this curve, we will get the curve actually decreasing from left to right. Okay. Alright, let's look at logarithm functions now. Now when we are given an exponential function a to the power y equals to x, we can change this to a logarithm function, where y is now equals to log base a of x. Okay, so which means a to the power y equals to x. When converted to log, we will get y equals to log base a x. So how do we do that? Let's look at the following example. In example 5, if we are given log base 3 9 of 9 equals to 2, then when we convert log into exponential, then we can say the base 3 to the power of 2 will be equals to 9. Okay. In example B, if we have log base 10 of y equals to 4, then we can say 10 to the power of 4 is equals to y. Okay. Please pay attention on the red line here. Okay. In example C, if we have log base 2 of 8 equals to 3, then we can say 2 to the power of 3 equals to 8. Alright. Okay. Example 6, you are asked to convert the following exponential function to a logarithm function. For example, we know 2 to the power of 5 is equals to 32. If we convert this into log, then we can say log base 2. Alright, log base 2. So this becomes a base of 32. The answer will be equals to 5. Okay. And 10 to the power of 0 is equals to 1. When we convert this to log, then we can say log base 10 of 1 equals to 0. In example C, 5 to the power of 3 equals to y. So this means log base 5 of y will be equals to 3. Okay. Okay, let's look at some of the properties of logarithm, or we say the formula involving logarithm functions. Okay, formula number 1, log base A of A. So if this is A, this is also A. Actually we can cancel log A and A. So the answer will be equals to 1. If we are given log base A of m to the power x, then this power we can take it out here. So we will get x log base A of m. Okay. For the third formula, we have log base A m plus log base A n. So when we have log A and log A here, actually we can take out log A. Okay, when we take out log A, then if this is plus, then we will multiply m and n. So we will get log base A m times n. In formula number 4, we have log A and log A here, but this time this is minus. So for minus, log and log A, we can take out log A, but minus we will convert to divide. So we have m divided by n here. Okay. In example 5, log base A to the power m. Now we can change the log base A to log base B. So how do we do that? So m will become the numerator of this fraction, and then the A will become the denominator. So log A, if we change to log B, we will get log base B of m over log base B of A. Okay. Now let's look at example 7. We are asked to find the value of log base 3 of 81. So how do we answer that? So for log base 3 of 81, the first step is we change 81 to 3 to the power 4. Okay. So now log 3 and 3 we can cancel. So the answer will be 4. Alright. In example B, we have ln of 1 over e. Now ln here represents log base e. Okay, e is an exponent, right? So when ln 1 over e, we can change ln to log base e, and then 1 over e, we bring e to the top, we will get e to the power negative 1. So now log e and e we can cancel, so the answer will be equals to negative.